Hello and welcome to today's lesson, which as promised will be on solving simple equations. So last lesson we discussed briefly what an equation actually is. I said it's what we've got here, something like x plus 3 equals 7. It's an algebraic expression, i.e. something with an unknown, which is our x, with an equal sign in it. So this is the expression. Just write that for now, and this bit, well, technically the whole thing, makes it an equation. Oh, too much undoing. So, how do we go about solving equations? I imagine almost all of you could look at something like x plus 3 equals 7 and immediately think, well, x equals 4 is what I'm looking for because 4 plus 3 equals 7. The other one, 2x minus 4 equals 6, is a little harder. I'll come on to that in a minute. When we're solving equations, regardless of how simple or complex there are certain rules of what we can and cannot do. And the fundamental rule is whatever you do to one side of the equals sign, you must do to the other side. So for example, if, say, I wanted to add 5 to the left-hand side of this x plus 3 equals 7, to keep the equation true, to keep it so that both sides are equal, I would have to add 5 to the right-hand side. Obviously, I probably wouldn't want to add 5, it doesn't make anything that easier. But what I could do, if I wanted to, is subtract 3 from the left-hand side. Obviously, I then have to subtract 3 from the minus side, from the right-hand side, sorry, what the hell. And I get that x plus 3 minus 3 equals 7 minus 3. Obviously, plus 3 minus 3 cancels, and we just get x, and 7 minus 3 is 4. And look, we get x equals 4, which, as I said, was the solution. So let's now have a look at this second one quickly. We've got 2x minus 4 equals 6. Now, generally, what I want to do is get all my unknowns on one side and all my knowns, or the constants, the numbers, on the other. So to start with, what I can do is to, as we say, carry the 4 across. We add 4 to both sides. So we get 2x minus 4 plus 4 equals 6 plus 4. So the minus 4 plus 4 is 0, so it cancels out. And we get 2x equals 10. And this brings me on to the next thing. We can multiply or divide both sides of an equals by the same number. So in this case, because I want to know what x equals, I might want to divide the left-hand side by 2. But in order to divide the left-hand side by 2, I also have to divide the right-hand side by 2. So we get 2x over 2 equals 10 over 2. So the 2 times x is going to cancel with the divided by 2. If you're not sure why, then check out my last week's lesson on the notation involved. Obviously 10 over 2 is 5, so we get x equals 5. And if you want, you can then go back and plug that in and check, and we get 2 times 5 minus 4, which is obviously 10 minus 4, which is 6, and that is what the equation was telling us. And we have reached the statement that 6 equals 6, which hopefully you can all trust to be true. So, as I just said, one of the things we want to do is get all of our unknowns, our variables, on one side and all of our knowns on the other. So if I had something like 3x plus 5 equals 2x minus 2, it's still an equation. We've got one algebraic expression being equal to another algebraic expression this time. Technically, every constant is an algebraic expression. it just has no unknown variables in. So what do we do here? Well, for a start, I know I want to get all of my numbers onto one side, so I might choose to say subtract 5 from both sides. And I'll explain why I'm subtracting 5 rather than adding 2 in just a second. So we get 3x plus 5 minus 5 equals 2x minus 2 minus 5. So the plus 5 minus 5 cancels and we get 3x equals 2x minus 7. Which is nice, but I've still got my unknowns, my x's on both sides. So to deal with that, what I'm now going to do is I'm going to subtract 2x from both sides. Now 2x is still just a number, so we can do this. Obviously we have to do it to both sides. So we get that 3x minus 2x equals 2x minus 2x minus 7. Obviously our 2x minus 2x is going to be 0 regardless of what x is. And we get 3x minus 2x equals minus 7. So what do we do about this 3x minus 2x? Well, 3x is just 3 times x, or x plus x plus x. 2x is just 2 times x, or just x plus x. So what I'm doing is x plus x plus x minus x plus x. Watch the brackets here, because when I multiply that negative through into the second bracket, the plus sign changes to a minus. And obviously we've got a plus x minus x here, so that cancels. Then we've got a plus x minus x there, and that cancels, and we get that equals x. So 3x minus 2x equals x. This is a general rule. If you have ax minus bx, that is going to equal a minus b, lots of x's. So we now have the equation being x equals negative 7. And there we go, we have solved it. And if we want, we can go back to our original equation and put that in. So we get 3 times negative 7 plus 5 equals 2 times negative 7 minus 2. 3 times negative 7 is negative 21 plus 5 equals negative 14 minus 2. Negative 21 plus 5, I'm going to move that off now. Negative 21 plus 5 is minus 16. Minus 14 minus 2 is minus 16. And we have a true statement. So, your turn now. Solve 4x minus 9 equals, let's go with 27. 5x plus 7 equals 2x minus 4. And 7x plus 3 equals 9x plus 5. I haven't worked these out, I'm making them up, so if you get some nasty fractions, I apologise, but deal with it. As always, do pause the video if you want to, otherwise answers are coming now. So 4x minus 9 equals 27. So we add 9 to both sides, we get 4x, so minus 9 plus 9. For my own benefit, I'm going to stop writing that out. 27 plus 9 is 36. And then we divide both sides by 4 to get x equals 36 over 4, or 9. 5x plus 7 equals 2x minus 4. Well, we can start by carrying our 7s across, or by carrying our 2x's across. Normally you'll want a positive number of x's, so I'm more likely to subtract 2x from both sides than I am to subtract 5x from both sides. So like here, I'm going to do 5x minus 2x is 3x plus 7 equals minus 4, then subtract 7 from both sides. 3x equals minus 11, and x equals minus 11 over 3. Generally, leave things as fractions unless otherwise stated. Fractions are more accurate than decimals because they convey all the information. Obviously, if you're told to leave it to a certain number of sig figs or decimal places, do that instead. But otherwise, fractions are more accurate, more correct, and also easier to work with in other expressions and stuff. So there we get x is minus 11 over 3, and finally we had 7x plus 3 equals 9x plus 5. So I'll write that again so I can see it. This case, I'm going to subtract 7x from both sides to get 3 equals 9x minus 7x is obviously 2x plus 5. Subtract 5 from both sides, we get minus 2 equals 2x, and then divide through by 2 to get minus 1 equals x, or x equals minus 1. So that's all for today. Quite a short one, but very important to know how to solve these basic expressions. The next lesson I'm going to go through, which will hopefully be quite an easy one after this, is just plugging in values into formulae. See, formulae or expressions, not the same as equations, but they are very closely linked, and hopefully you'll see that